Radhe Radhe. So in this video I'm going to discuss the minimum operation to make array equal to target, which occur in today's LEETCODE challenge. So if you have any doubt regarding this, you can pick me up on Instagram. Even you can join my Discord server. I will put both links in the comment section. The problem statement is very simple. You're given like one array and a target array. You have to make this to this, and what you can do is you can select a sub array and increment 1 or decrement 1 from the whole thing and count it as one operation. So you have to find the minimum number of operations that you have to perform to make them equal. So for this it is very simple. If you are adding 1 to all the elements, so except this element, all the elements are becoming the target value. So after you have added 1 to this, it becomes 3, and then again if you add 1 to this, it becomes 4. So basically plus 1 to the whole array, that is one operation, and plus 1 to this specific element, and that is plus 1 operation. So it becomes 1 plus 1, that is 2. Okay, but the most important thing is this. Okay, like if you want to get the knowledge like why this happens, like I'm going to discuss the solution. So basically let me give you a spoiler. The spoiler is that this is a greedy approach. Okay, now the question is why this is a greedy approach and not a DP approach or some recursive approach, something like that. Okay, so if you're going to consider this 1 3 2 and 2 1 4, so what you can do is you can add 1 to this, right? But from here you have to subtract, but over here also you have to add. Okay, now let's say if I'm going to add here and add here, that is throughout the whole thing. So 1 3 2 becomes 2 4 3, right? Now in order to make this 4 to 1, what you can do is you can make it minus 3, that is 3 more operations. That is 1 operation then 3 more operations. So now it becomes 1, and at this position from 3 to 4 it becomes another 1 operation, right? So 3 1 1, that is 5, right? This works. But there is another approach. Okay, that is if you're going to just increment this one and leave the remaining. Okay, so this one, so it becomes 1 operation, and then you can decrement this for 2 operations. Okay, and then this for again 2 operations, which is also equal to 5. But if you notice one thing, in this case you are not looking to the elements which are after that. Okay, you're just checking the elements which are before that and that element. So this is the greedy approach, because this also works and this also works, because if you're going to add something to this, so you're going to subtract this from here. So basically it is better just to follow the greedy approach. So it will also reduce the complexity of the whole code, the time complexity, and it will also like give you a better understanding of the problem. So now let's jump into the solution. So what you can do is, let's say answer. Okay, answer is equal to 0 initially. Now let's say previous. Okay, previous is the element which is occurring just before that. So previous, let's just make that. Okay, so what you're going to do is you're going to have a difference array. Okay, array of difference, where difference of I is equal to sum I minus target I, or you can do the reverse also. Okay, that is target I minus sum I, because I think this is what the question demands. So target I minus sum I. Okay, now what is the previous element? Initially it is difference of 0. Okay, now what you can do is you can run from 1 to n minus 1. Okay, that is ignoring the first element. And remember one thing, answer initially is not 0, it is the absolute value of difference 0. Why is it so? Because if you are going to like over here 2 minus 1, so what was the first value? It was 1, right? Over here it was 4 minus 3, that is 1. So over here also the first value should be 1. That is, you have to apply one operation. At least one operation has to be applied on the first element. That is what we mean. Okay, so at least one operation. So answer is equal to absolute value of difference of 0, and previous equal to difference. Now you have to check if previous and, okay, let me like write it in a simplified form. If previous and difference of I are having the same sign convention. What does this mean? That if this is in negative, this will be also in negative, and if this is in positive, this will be also in positive. So how we are going to do this? Lesser than 0 and lesser than 0, or greater than 0 and greater than 0. I hope you're getting it right, what I mean. So in this case, if this happens, under that you're going to apply another operation. Okay, you have to check if the value of absolute value of f is lesser than the absolute value of difference of I. Okay, so let's say you have applied some operation, that is f, earlier, but now the value of this difference, it is greater than that. So what you have to apply, how many more operations you have to apply? This minus f, right? So answer plus is equal to absolute of diff I minus absolute of f. Okay, done. Now we have to change the value of f. Okay, now what if it was greater than equal to this? So if it is greater than equal to this, it doesn't, like, we don't need to give it a try. Okay, because if the previous, like, if we are applying x number of operations before this, and at this position to make it 0, you need x minus n number of operations. So it doesn't matter, you can just simply tell that from the previous operations this can become 0. Okay, because it is going to apply as a sub array. Okay, so if this occurs, okay, well and good enough. Now you're going to get out of this whole if thing, okay, and go to the else section. Else you have to, what you have to do is answer plus is equal to absolute of difference of I. Why is it so? Because if the sign conventions are different, okay, like over here what we did, so initially what is the difference array? It would look like 1, -2 and 2, right? Now once we are getting that the sign convention has changed from the previous element, okay, then we have to stop the sub array over here and start again from here. So how we were starting, it was absolute of difference of 0. So it is going to be answer plus is absolute difference of I. And after you have done the whole thing, remember one thing, you have to make, okay, so what they're doing previous, okay, so what is f? Okay, I think I missed up one thing. F is actually previous, okay, x is actually previous. Now previous is difference of I, and we can go to the next element. That's it. Okay, so what we are basically doing, if we have a difference array, okay, let's say this, now let's say this is positive. So until and unless we are accounting all positive numbers, so we can do it in one go. Okay, so let's say there is 2, 5, 4. Okay, 2, 5, 4. What you have to do is apply 2 operations to this plus this. Okay, this plus this. But remember whether you have to apply this on this or not. Okay, this is the main question. So does it affect you if you are applying this on this or not? So if you are going to apply 2 on all the elements, so it becomes 0, 3 and 2. And then if you apply 3 on this and 2 on this, which you can do obviously, because like if you're going to apply one operation over here and the remaining 2 you're going to over here. Okay, so 2 plus 1 again. Okay, 2 plus 1, that is 3 plus 2, that is 5. Total in 5 operations you're doing the whole thing. Okay, now how we are going to simplify this? 2, 5. Okay, now since this is greater than this, so what is the new value of this addition or subtraction? It becomes 5 now. Okay, now how many operations extra you have to do for this? That is 3, right? So initially it was 2, then 5 minus 2. Okay, you're going to do 3 more operations. So initially it was 2, and then you have to go 5 minus 2, that is 3 operations. But when you are doing 3 operations, you're already covering this 2. Okay, this is the most important thing. If you are doing 3 operations, so you're already covering this 2, and since 4 is lesser than 5, so we can give your justification based on this. So 2 plus 3 is 5. Okay, which gives us the answer. For here also, if we get a check, 1 minus 2, 2. Okay, 1 minus 2, 2. So the answer is initially 1. Okay, now the sign changes, so answer is now 1 plus 2, that is 3. Again the sign changes, so the answer is 3 plus 2, that is 5. You can see that the answer is 5, right? Now for this 3, 5, 1, 2, so what does the difference array looks like? Let me write it over here. 4 minus 1, 4 minus 3, 1, 6 minus 5, 1, 2 minus 1 5 1 4 minus 2 2, right? Over here you can see that if you're going to apply one operation over here, it goes on continuing. Okay, so if this is like the sign convention is the same, and what was the condition when you have to change this answer? Answer is initially 1. Okay, answer is initially 1. Now do you have to change the answer because the sign conventions are same and previous is never lesser than difference of I? Okay, the previous element is never lesser than this until and unless you encounter this position where the previous element is 1 and this is lesser than this, right? So if this is so, how many operation extra we have to do? We have to do answer plus absolute of difference of I minus absolute of previous. Okay, so 2 minus 1, that is 1 more, so that is 2. So answer is 2. You can see this. Okay, so that's it, how we are going to do this. So that's it from my side. Thank you. If you still have any doubt, ping me out. It's okay.